After I recorded videos for properties of the derivatives and chain rule, and lastly implicit differentiation, I decided to explain some cases here. So in one case, let's say we have d by dx of negative x over y. It's going to be equal negative 1 over y. Some calculators of derivatives will give you such result. Other calculators for d by dx for negative x over y will give you the following result. Negative x prime y, I'm applying quotient rule, minus y prime x, right, over y squared, and it's going to be equal, derivative of x is 1. So here we have only y, minus x, and derivative y, it's going to be dy by dx, and divided by y squared. So you can take either this as a final answer, or you can break down if you need. It's going to be negative y over y squared, and plus, because you have, look, minus here, so it's going to give you plus x over y squared dy by dx. Now, let's understand why some calculators will do this one way, another calculator do another way. And let me finish. This is 1 over y practically. So 1 over y plus x over y squared dy by dx. The thing is, if, let's say, in this case, when we are getting negative 1 over y is not represented as a function of x. It's not y of x. No. It can be non-differentiable function, or it can be a real number. Okay? In that case, so negative 1 over y comes out, and you take derivative of dx. Right? Which is going to be 1, and the result you get negative 1 over y. Different story is when y is represented as a differentiable function of x. Okay? And in that case, so when differential term involved y, and this y is a function of case, then we must apply chain rule, because we assume that y is definitely implicitly as a differentiable function of x. This is why in another case we use quotient rule, and we leave dy by dx, like here. So in this case, we have y is a function of x. Okay? You understand the difference? So how you gonna figure it out? One way or another, it will be given in the condition, or somehow you will understand. It's somewhere will be mentioned, and you will know. Okay. Now, and the other thing I wanted to show, let's say d by dx from negative x over y, I'm going to represent as a product x, y to power negative 1. It's the same thing, right? So I'm going to use product rule, and I'm going to get the same result. So let's see. here I'm getting negative, so it's going to be what? Derivative of x times y to negative 1, and then plus derivative of y to negative 1 times x. So derivative of x, negative x prime y to negative 1, and then plus, it's going to be derivative of y, right? Derivative of y, it's going to be negative 1 times y to power negative 2, chain rule, and we are getting in and taking derivative of y by dx. And then we multiply by x. I'll put here in front. All right? So as a result, we are going to get derivative of x prime is 1, so we are getting negative 1 over y, and plus, actually, yeah, it's here it's negative x. Hold on. Plus negative x. Yeah, because we have negative, right? So we will end up plus x over y squared dy by dx. So if you compare differentiation of quotient rule using quotient rule or product rule, we are getting same result. Okay, now implicit the differentiation, we are using two equations. So if I have, let's say, negative x over y, right, is equal to, then I am applying implicit differentiation, okay? It's going to be d of dx from negative x over y, and is equal d by dx of 2. And we go from there. So the important difference, one more time, between this one and these two ones, because it's the same way, is that to find dy by dx implicitly, we have to realize that the differentiation is taking place with respect to x. That's the first thing. Although we have x and y, but differentiation take in respect to y. If you need in respect to x, if you need in respect to y, you just can write down d by dy, and everything will be switched. Whatever the way we were treating y, now we will treat x the same way. Okay, so differentiating with respect to x. What does that mean? That means that when you differentiate terms involving x alone, you can differentiate as usual, like d2 dx, x squared plus 3x, for example, as usual, will be 2x plus 3. However, when we differentiate terms that involve y, then we must apply chain rule. Why? Because we assume that y is defined implicitly as a differentiable function of x. So if it's not a differentiable function of s, like x, like here, so one way or another, it will be mentioned in the condition. Okay, hopefully this short video brought clarification, because I know quite a few students get confused. In one case, one way, another case, another way, especially when they check on calculators. One calculator give one result, another calculator another result. Then you can understand how we treat. in what calculator how treats differentiation of y. Okay, thanks for watching, and as always, if you have questions, put in the comments and I will answer. See you next video.